Okay, so for the real number system, notice what our two major groups are in the real number system is these very outer boxes. So we have the rational numbers and irrational numbers. And then within rational numbers, all of these boxes inside it also are part of the rational number category. Whereas irrational number, it's kind of a loner over here with nothing else. So let's just go through what each type of categorization is in the real number system or classification. So natural numbers, those are going to be like your counting numbers, kind of like what you start off with where you're using your fingers to count. And then, of course, it doesn't stop at 10. You know, you could keep using your fingers to go to 11, 12, 13. So those counting whole numbers. So if you want to make a note, so whole numbers. So what would be some, let's put a few examples in each box. So what are some examples of whole numbers? 1, 2, 3, any others? What'd you say, Ethan? 5, 4, you know, it could just keep going. So whole numbers that we could just keep counting on our fingers. All right, then we have whole numbers. So again, it includes the box inside of it. So it's whole numbers plus natural numbers. Plus 0, exactly. So an additional one would be 0. So this one is natural numbers plus 0. So it includes the box inside of it. All right, then we have integers. So again, integers include whole numbers and natural numbers, but what else would integers have? Negatives as well. So this one is whole numbers and opposites. So these are your notes. Do what makes sense. You could say whole numbers and opposites, or if you would prefer to say whole numbers and negatives, right? What makes sense to you? But remember, technically that's the opposite. And so let's write some examples of integers. -3. Someone else? -2. -5, okay. -4. All right, any others? We're good? And then rational numbers. So again, rational numbers are also going to include integers, whole numbers, and natural numbers, but do you know what? It can be a fraction, exactly. So we'll say integers plus fractions. And remember, fractions also can be decimals, you know, like if we do, like what's 1/2 in decimal form? 0.5. So when we're talking about the decimals, so let's first do some fractions here, and then let's look on our calculators of how they would convert to a decimal. So give me a fraction. 3/4. And then test it out in your, so remember there's two different ways you can convert to a fraction. You can use the green alpha and then the button to the right, and you can do 3/4. Now that's going to keep it in fraction. So do you remember how you convert that to a decimal? Math, and then where do we go? 2. So see how 2, it says, is convert to decimal? So then you would do 2, enter. So that equals 0.75. Give me another fraction. 5/8. So now let's see what that would be. Another way you could do it is you could just do 5 divided by 8. and then it'll give you the decimal. So remember, just use the math to convert it. The first one's fraction, the second one's decimal. So use that whenever you need to convert. So then that one's 0.625. And then I'm going to give you one more. What about 1/3? What is 1/3 in decimal? 33333. So what do we use to show that it's a repeating decimal? A line over it. Yeah.
When you use like fraction numbers, like can be a fraction, or it could be irrational, doesn't mean it has to be like non-terminating or non-repeating.
You got it. Yes. So what I'm getting to for rational, these decimals, they either terminate, which means they end, they don't go on forever. So down here in the parentheses, they can be either terminating or repeating decimals. And then I'm going to use yellow. I'm just going to highlight so that we're not like using so much of the highlighter. I'm just going to highlight around the rational numbers box just to show that all of these numbers are included in our rational numbers. If you want, you could also, I guess, do the outside of each box. So the main idea is we want to know that all of these numbers are rational. Integers, whole numbers, natural numbers, terminating or repeating decimals. These are all rational. Question? So irrational numbers are not going to fit within these rational numbers. So if rational numbers can be fractions or terminating or repeating decimals, then what would our definition for irrational numbers be? Non-terminating, non-repeating. And then they can also be represented as a fraction. And when, to be more specific with that, hold on, let me look at that. Or they cannot be. So they cannot be expressed as a fraction of integers. So whole numbers and their opposites, and they're non-repeating, non-terminating. Yeah.
When you highlight, how do you get it so perfect?
Why you're not doing it?
No, because like when I highlight, it's either too high at the angle or
Because I have a lot of years of experience highlighting.
it was me just struggling trying to keep it straight. And it was
The more you do it, the more accuracy you get. It's a lot of years of it. Okay, so what would be some examples of irrational numbers that they can't be expressed as a fraction of integers and they're non-repeating, non-terminating? What number? Pi, yep. So let me, because in today's activity, you're going to be having to use your calculator to calculate different rational and irrational numbers. So do this with me because you're going to need to know in the next activity. So to do pi, remember, all the operations using the blue second button. See all the words and symbols that are above each of these keys that are in blue. That means we would use the second, the blue button. So do you see where the symbol pi is on your calculator? The caret. So you would do second caret, and then it'll give you a pi symbol in there. So everyone do that. Second caret, because there's that little pi symbol above the caret. Yeah, you'll just be calculating it, like, you'll do it today. We'll be using pi, but you have your calculator to do it for you.
So instead of April, we'll use this.
So yeah, then notice how it's going to give you this. Of course, this goes forever. Our calculator can only show part of that. So for pi, we can just put the approximately equal to. So remember that tilde symbol shows that it's approximately equal to, because it's giving you a rounded number on your calculator, because it can't go forever. So we can just write 3.14159. And then, so in the activity, when you get an irrational number like that, you can just use ... to show that it keeps going forever. So use the ellipses to show that it keeps going forever.
Is there ever an end to pi?
There is no end. It will go forever.
Has science proven that?
Yes. It's an infinite number. Okay, so that's one that everyone commonly knows. Do you guys know any other types of numbers that are irrational? Anna?
Infinity.
Okay, so infinity, for that one we can't, I don't think we can really represent in the number system, because yeah, we can't really represent that. It's just showing that it goes forever, so it's not an actual number. Any other ideas of irrational? Siri doesn't know either. Going back to your graphic organizer from yesterday, we did the, which one? Okay, that's what I was going to get to. Square root of 7. So you're also going to have to do square roots today. Do you guys remember? We've done square roots a little in here. Do you remember how to do the square root symbol on your calculator? Where's the square root symbol? It's one of the blue, the x squared. So you would do second x squared. So everyone put the square root symbol in there, and then put 7, square root of 7. And then what does that give you? Now, in today's activity, you're going to have to see if it is rational or irrational. A really good way to use your calculator for that is let's see if this can convert to a fraction. So if you already have a decimal on your calculator, how do you convert it to a fraction? So we press math, and then remember the first one is fraction, so you can just press enter, enter. If your calculator just keeps it as that same decimal, that means it can't convert to a fraction. So this one would also be irrational. So again, use the approximately equal to 2.645 that 7 would round up to an 8. So then we're using those ellipses to show it keeps going forever. Do you know of any other square roots that would be irrational?
Like not go forever?
That would go forever. What are some other square roots that would keep going forever? Square root of 5. So test out square root of 5. Does everyone agree square root of 5 would be a non-repeating, non-terminating decimal?
Yep.
Yep. So for these, it's going to... Now, what are some square roots that would be rational numbers? Square root of 1. And what does the square root of 1 equal? 1. So that we could technically put that in whole numbers if we want to add that over here. Square root of 1 equals 1, so that's a whole number. Actually, that's technically a rational number, I guess, or a natural number. What other square roots are rational? Which one? 4 square, and what does the square root of 4 equal? So that could go in natural number square root of 4. So just know that some square roots are rational, but some are irrational. So this one was 2.236. All right, now I'm going to highlight the irrational numbers, the border green. And then I'm going to glue this on the next page in our notebook. All right, if you're following along with my same page numbers, I'm on page 42.
So, I'm kind of,
Hold on one second. And this is lesson 20.1.